Right, so we are going to start out today, Unit 7, Learning Target 3. Today we are going to, well, first we identified what polynomials were and classified them in Learning Target 1. Learning Target 2, we added and subtracted them. So today, Learning Target 3, we're going to multiply them. Okay? And here's the cool part about this. You've already multiplied. We're using rules that we've already learned. So I'm not teaching you anything new rules. I'm teaching you a new procedure. Okay? So if I were to say to you, I want you to write this word. Okay? So this is a property you learned, I was going to say last year, but you learned it actually way before then. You may not have known that that's what it's called, but I think I've seen it touched upon in my daughter's 4th grade work. Okay, so if I were to give you this problem and ask you to do that problem, and if your goal was to get the answer as fast as possible, what operation would you do first? You would do what?
I would do like 5 times 4.
Would you? I would, if I wouldn't have just written that word there. If I wouldn't have just written that word there, what would you do? You would add 4 plus 3. There's no way you would think to do that first, right? So 4 plus 3 is 7. 7 times 5 is 35, right? That is like the main way, because that's what order of operation says to do, right? It's the most efficient way. Add what's in the parentheses, okay? We are learning, actually in 7th grade class today, the distributive property. So this is their notes today. So we are starting out with the distributive property, and they've never heard of this before, maybe a multiplication fact that can be broken apart into the sum of 2 smaller multiplication facts. So this kind of goes along with, we had a big discussion first hour. Instead of teaching kids to just memorize 6 times 7, which yes, they do just need to memorize their multiplication facts. But if you're breaking it down, they're using the word decompose on a smaller level. They're saying, we could if we needed to. We may not want to, but we could break 7 down into 5 plus 2, right? And after I took that 5 plus 2 from the broken down 7, could I just multiply the 6 times that sum? And that's like just doing the 6 times the 5 and the 6 times the 2 separately. Are you following? And 6 times 5 would be 30. 6 times 2 would be 12. And add those together, and you get 42. Okay? And then somebody says, that's that stupid new way to do it, right? Okay? And we had this conversation about this, and I will say this. That new Common Core, Eureka Math, whatever you want to call it, when we introduced it, it was given to you guys in probably, I don't know, you were in 4th grade or 5th grade, where you had been taught one way from kindergarten up, right? So your brain was working one way, and then like, poof, here you go, 5th grade. I'm asking you guys to change your way your brain we have programmed you to look at it a different way now, right? Okay? And it didn't work, did it? It just got confusing for you. But as a math teacher, and as a mother of a child who is in kindergarten right now, who is known and has not learned any other way but this way, he is jamming on his math facts right now because of the way this is broken down. You know what I mean? They'll do something called 5 sticks. If you have little siblings in kindergarten or something, they'll do 5 sticks. And everything goes by 5s. Okay, so that's a 5 stick. He doesn't even need to count them because he knows there's 5 there, because they're programming him to do that. So when they give him a picture and they say how many, he goes 7, like that. Because he knows, I said, how do you know that so fast? He goes, because 5 plus 2 more is 7. Do you see what I mean? Like if his brain, from the time he was the first in school, is being trained to look at it this way. So then when we put a number to this and a number to this, he's already going to know it, right? So it's a new way of thinking, but he's okay with it because they never just taught him 5 plus 2 is 7. They're teaching him the concept behind it. Okay, so that kind of understanding it from that perspective. And you know what? Let's think about this. You guys have done this before. You've used this distributive property. If I asked you to multiply 3 times 4.25, A, first thing you probably would do is grab your phone to do it on the calculator, right? B, if you didn't have a calculator, some people might, without thinking, just do this, right? 3 times 5 is 15, waste of time, right? Okay? Anybody have a quicker way to do it in their head? Anastasia? Yes. You just pretend like that 25 cents, I'm calling it money because it's easier. So what she just told me she would do is break down that into that. She may not pick up a pencil and write it that way, right? But she said, first I'm just going to do 3 times 4. Because that's 12, and I can do that easily. And then, don't forget about those 3/4 also. Because those 3/4 gives you 75 cents. So that's $12.75, and that didn't even hurt your head, did it? Right? You just broke it down. You used the distributive property without even knowing it. Okay? So this is something that we are doing. We're breaking it down. I'll never forget. Like, this is going to just blow your mind because you'll be like, oh, I wish they would have taught me it this way from kindergarten. For the first time, my daughter was doing this math fact. As a math teacher and as a 40-year-old woman who had learned it this way since the time I was in 3rd grade, she started to do her math fact, and she said, 3 times 5 is 15. And I went, hold the phone. What are you doing writing that 1 right there? That belongs up here, sister. And she goes, no, that's not what Miss McCarthy told me. And I said, well, what's she teaching you? She goes, just let me finish. And she says, 3 times 5 is 15. Then she goes, and I was shocked. She goes, 5 times 40. Most kids would look at that and think it's a 4. But it's in the tens place. So if you have 4 tens, that is a 40, right? And so 5 times 40 is 200. Right? That was pretty great. Because instead of teaching her some process of put the 1 up there, what does that really teach you? It teaches you nothing. So you want to take that 40 plus 3 and you want to multiply the 5 times the 3 and the 5 times the 40 and add them together, right? So if she wanted to do 68 times 4, she did 8 times 4 and got 32. Then she did 60 times 4 and got 240 and got 272. And it makes more sense, doesn't it? Doesn't it? I mean, you may look, like, how many of you followed that? Like, that makes sense. But it goes against everything you were taught, right? Okay, so, but if you had learned it this way from the beginning, you may have a better concept of what these numbers really mean. Because that's not a 4. And that's not a 6. It's a 60. And it's a 40. Okay? So, I'm kind of digging the way that Alex is learning about this number concept there as a math teacher. Okay? All right, so that was just a little side note. So let's get back to how this relates to what we're going to do here. Okay? That's my little plug there. So if I would not have written this word and I asked you to do that problem, you would probably say 5 times 7. Okay? However, there is another way to do that, just like we learned, is that you could take that and break it apart. And you could do the 5 times the 4 and add it to the 5 times the 3 and get 20 plus 15, which is 35. Okay? Something called the distributive property, and the reason I'm reviewing it is because you really need to know how to use this property to do today's learning target 3. Okay? So let's see what this means. If I were to just take that 4 and change it to an x and then ask you to do that problem, if your instincts said, go do what's in the parentheses first, and you went to do it, you couldn't. You can't do x plus 3 because they're not like terms. It has to be a 3x, right? Or constants together. So this is where the distributive property has to be used. You have no choice. You have to distribute, right? So I'm going to distribute the 5 times the x and the 5 times the 3. And just do them separately like that. So 5x plus 15. You need me? Okay. Try this one. 4 times 3x minus 8. And then 4x times 2x minus 6. Careful on that second one right there. Okay, so try those two. All right, be careful on that second one. All right, 4 times 3x. Sorry. So you did 12x minus 32, right? Mm-hmm. And this one, what did you do?
8x squared.
Did anybody else put a squared? What's 4x times 2x? 8x squared. And 4x times a negative 6 is a negative 24x. So here's the cruel joke that is about to be played on you again. Remember how first we added the exponents when we multiplied them? And then learning target 2 we added, which means we didn't add them. And now we're back to doing both, basically. Okay? So we need to do a little refresher of our memory here. 2x plus 4x is 6x. But 2x times 4x is 8x squared. You have to be able to make that distinction in today's notes, or it's going to get ugly, okay? So then, what if I asked you to take this, 4x to the third, which is a monomial, a cubic monomial to be exact, and asked you to multiply it by this, let's make that a negative, asked you to multiply it by this quintic binomial. So, monomial times binomial using the distributive property and what you know about when you multiply exponents, this times this times that. No work to show, just do it. Negative 4 times negative 2 is positive 8, right? 3 plus 2 is 5. Okay? And we're adding them because that's what you do when you multiply. Negative 4 times negative 3 is positive 12. And 5 plus 3 is 8. Got it? Okay, I don't need to do much more of these because I got to show you a couple more things. All right, what about this craziness? Negative 4x cubed y to the fourth times 2x y to the third minus 3x cubed plus x cubed y to the seventh. Woo. Okay. So distribute. And treat this as 3 little mini problems. So negative 4 times 2 is negative 8. 3 plus, be careful, 1 is 4. And 4 plus 3 is 7. They're just little mini problems. Do you see what I did? Negative 4 times negative 3 is positive 12. 3 plus 3 is 6. There's 4 here. No y's here. Y to the fourth. Negative 4 times positive 1 is negative 4. 3 plus 3 is 6 again. And 7 plus 4 is 11. Okay, are you with me? Okay, so that's what I meant when we hadn't really learned. We've done that before. We've just done it as separate problems, right? I've never put them all in a row like that. So big deal. Are you good with that? Okay, what I would do after I'm done distributing, though, is look to see if any of them are like terms. 4 and 7, 6 and 4, 6 and 11. Nope. If they were like terms, I would add them. But they're not, so I don't. Okay? Moving on. Okay, so this is where it starts to get a little tricky. We're going to multiply a binomial times a binomial. So 3x plus 4 times 2x plus 6. Okay. So you have two options. And you know how we were just talking about old school versus new school kind of methods? Okay. There are two different methods that I'm going to show you. I'm not going to tell you what's the old school and which one's the new school. I'm not going to tell you which one I prefer. I'm going to show them both to you and let you decide which way you like better. Because sometimes people will do the way that I kind of tell them is my favorite. Okay? So we'll just say option 1 and option 2. I'll give them names. You're going to watch them both and decide which one you like. We're going to just use the distribute. And then there's also something called the box method. All right. So option 2, option 1, distribute. So let's take this 3x plus 4 and this 2x plus 6. And on a little side note, this almost looks like the quiz we just got passed back, except what was in the middle of it? Right, a plus or a minus. So if I had 3x plus 4 and then a plus 2x plus 6, you would add them, right? This answer would be 5x plus 10, right? Without that little sign there, because that could look really similar. Be very careful. If there's an addition or subtraction sign in the middle, you have to do it one way. This is a totally, totally different method, okay? So, for those of you who like to distribute, let's do something here. Let's pretend like that 4 wasn't there. Let's pretend like the only thing I'm asking you to do is take that 3x and distribute it through to that. A piece of cake, right? You would just do the 3x times the 2x, and then you would do the 3x times the 6, right? So let's do that. Let's do that first. And I'm going to use 2 different colors. If you have 2 different colors and you want to, that might be helpful. So the red arrows are going to say 3. I'm distributing a 3. So distribute the 3x. So that's going to give me 6x squared plus 18x, right? So then the next thing I'm going to do is distribute. Just as soon as I can find my green pen. It's going to be Christmassy. I'm going to cover up the 3x and now distribute the 4. Right? So that's going to give me 4 times 2x, which is 8x, and 4 times 6, which is 24. So I color-coded it to kind of show you where the red terms came from, where the green terms came from. I distributed the 3x, then I distribute. So it's like a double distribute, right? Isn't that all it is? It's a double distribute. So now, what did I say you should do always after you distribute? Look to see if you can what? Those are both x's, right? So I can't combine anything else with that. I can't combine anything else with that because it's a constant. But the 18x plus the 8x is 26x. And it's in standard form. 2, 1, none. This is my answer. 6x squared plus 26x plus 24. That's the answer. Okay? Ready for box method? You start the box method, would you know, by drawing a box. And then because I'm multiplying a binomial times a binomial, I make a 2 by 2, right? And then I take one binomial, and it doesn't matter where it goes. I'm going to put 1 here, 3x plus 4, And then I'm going to put the other one over here, 2x plus 6. And notice the sign that's in the middle doesn't go in the middle because it's not the sign. It's not an operation. It's not addition or subtraction. That's a positive 4 and a positive 6. And then, you know how to play Battleship, right? You say E12, and then you follow it like that. So I'm going to take these two. Have you ever, this is another thing, lattice method for multiplication. Have you heard of this at all? Okay, I'll show you something in a minute. 3x times 2x is 6x squared. 3x times 6 is, you seeing it? 18x. 2x times 4 is 8x. You don't need to put the plus sign. And then 4 times 6 is 24. And then I look to see if I have like terms. And I do. And then you use what answers are in the box. I just want you to see something. Don't you still see all the same terms? They're just kind of in line here, and here they're in a box. So 6x squared plus 26x plus 24. Okay? Whichever method works best for you. So, first impression. Raise your hand if you like the distribute. Like if that to you seemed like something that would more natural. Okay, raise your hand if the box method is what. Yeah. Okay, that's okay. Okay, so let's try this right here. Try this. Pick a way, whichever way you like. 2x squared minus 4x times 6x squared plus 5x. Go with your instinct. What is your instinct way to do that? We're do a little experiment here. Which way feels the most natural to you? And then do it that way. So which way do you think is the old school way? And which way do you think is the new?
I think the new way is the box.
Yes. Yeah. So it feels more natural for me to just do a distribute, double distribute. So I'm going to distribute this first. So 2x squared times 6x squared is what? 12x to the 4th, because I'm multiplying, and when I multiply, I add the exponents. 2x squared times x to the, or 5x is 10x to the 3rd. Check your exponent. Where did that 3 come from? Because 1 plus 2 is 3. Now, ignore that and distribute a negative 4x. Negative 4x times positive 6x squared is negative 24x to the 3rd. Do you have a negative there? Because it's a negative 4 you're distributing. And then negative 4 times positive 5 is negative 20x squared. Okay, so now I have to look to see if I can combine any like terms. Can you? Yep. So I'm going to have 12x to the 4th minus 14x to the 3rd minus 20x squared. Think you got it? And, okay, if you did box method, it would just be set up the exact same way. You would just put your 2x squared here and your negative 4x here, then your 6x squared here and your 5x. And if those were flip-flopped, is that okay? Yep, it would totally work, okay? All right, how about, I'm going to show you one more problem. What if I asked you to do a binomial times a trinomial? So like 3a squared minus 4 times 6a squared minus 2a plus 1. You would do it the exact same way. If you were distributing, then you would just distribute it to 3 terms instead of 2, right? So you would distribute the negative 4. And if you did a box method, then the dimensions of your box this time would be what? A 2 by 3, right? So this would be 6a squared. So go ahead however you want to do it. Can you multiply a times b's? Well, never mind. I put b in my other problem. It looks like a lot, but then now I just have to go back and see if I have any like terms. 4, 3, 2, 1, constant. 18a to the 4th minus 6a to the 3rd minus 21a to the 2nd plus 8a plus 4. What's that? Yep, sorry, thank you. Minus. Okay? All right, I think we got this. Okay, that's really all there is to it. So you either are double